Hi, in this question we are given a circuit of 24 volt and there are 3 resistors 2 kilo ohm, 6 kilo ohm and 1.5 kilo ohm. And there are a couple of solutions given. The statements given, we have to see whether those are true or false. So the first statement is current I through the battery is 7.5 milliampere. For that we will have to find the total equivalent resistance of the circuit. Now if you see R2 and RL are in parallel. So the parallel circuit resistance will be 6 into 1.5 by 6 plus 1.5, that is 9 by 7.5 added to 2 kilo ohm in series. So the total resistance will be 3.2 kilo ohm, right? Now for finding current we will divide potential by this total resistance, which is 24 by 3.2. Okay, and that works out to 7.5 milliampere. 3.2 is the total resistance, so 24 by 3.2 is 240 by 32, which is 7.5. Kilo ohm means obviously, I have not multiplied with 10 to the power 3 here. So kilo ohm will lead to milliampere only. Yeah. Now second one. Second one says the potential difference across RL is 18 volts. So we have to figure out what is the potential difference across RL or R2. So the equivalent resistance of this RL and R2 in parallel was 1.2 kilo ohm and current was 7.5 milliamp. So potential difference across R2 or RL would be 1.2 into 7.5, which is 9 volts, right? So that statement is wrong. Part C. This is actually a JEE mains question, advanced question, but I found it very basic, so I sort of added that in mains. C, ratio of power dissipated in R1 and RL is 3. Now we'll find out power dissipated in R1. That will be V square R1 V square, which is the potential difference across R1, V R1 divided by R1. So the potential difference across R1 will be 15 into 15, 7.5 milliampere into 2 kilo ohm, okay, divided by 2. Now power dissipated in RL would be again V square by R. We have the V, which is 9 into 9 divided by, what is R here? 1.5. Right? I'm ignoring 10 to the power 3 everywhere. Reason being, we are doing ratios. So we have the 10 to the power 3 on both the sides, numerator and denominator. These numbers take time because we don't use calculators. So this really doesn't look to be a case of 3. So power dissipated ratio is not 3. I didn't even solve it, but this is clearly not a case of 3. Okay, so now D. If R1 and R2 are interchanged, magnitude of the power dissipated in RL will decrease by a factor of 9. Now this we have to work out by interchanging R1 and R2. You see, you got to do good time management. So you don't have to actually, get into, doing it to the last number or the whatever. You got to work it out and see if it is sort of fitting in the overall number. Something very close and something which matches with, the option there, is the right thing to go by. Because if you waste too much time calculating, if you waste too much time on couple of sums, you will not have time for a couple of, easy questions there. So try get more and more low hanging fruits first, and then you work on the slightly more complex questions. which you think will take more time or may not be sure types. So that is the right strategy for any exam, be that your board exam or JEE or whatever. In JEE it matters more. So here I am doing the numbers for you. So the new parallel circuit resistance was 3 by 3.5 and 6 is now in series. So the total becomes 24 by 3.5. Now we'll calculate power dissipated in the potential difference first between the 6 ohm one and the parallel circuit one, and use the same V square by R concept. So sometimes your numbers are very confusing. So you gotta look back, and because if you sort of pick up wrong numbers to begin with, you are bound to make mistakes, and you'll go back again and redo everything. So I mean, that has been my experience. I really get confused with too many decimals here and there, and I do tend to make arithmetic mistakes. I prefer dealing with ABC, XYZ because there's not too much of calculation I'm gonna do there. It gets slightly boring, but that's about it. You can't help much. So 3 by 24 and 24 is 23 volts. That is about the 3 by 3.5 ohm resistors, which is the parallel circuit. Now power consumed across RL is this 3 into 3 divided by 1.5. While we know that the previous power dissipation calculated was 9 square by 1.5. Now 9 square is obviously 9 times, so this is 1 by 9. So yes, this statement is correct. Thank you. This really took a lot of your time and my time. Thanks.